Hello guys, it's the tutor, and in this video I'm going to show examples of using the power rule on polynomial and rational functions and going step by step on how to find the derivative of each of these functions. So first we have f of x is equal to x cubed plus 3x plus x squared. So we're just going to apply the power rule, which I'll write it here again for anyone in case they've forgotten. So let's say you have x to the n d over dx, that is just equal to n times x to the n minus 1, right? So we're just going to apply that rule separately to each of these terms. So if you do it to that, it's going to be 3x squared, apply it to 3x, it's going to be plus 3, apply it to x squared, it's going to be plus 2x. That's your derivative function. F prime of x for this one. So you have a polynomial function and you also have a rational function. Not irrational, rational. So you have 64 times x to the 63. So you have n, which was 64 in the front. Then you have n minus 1 to the exponent of x. X to the exponent of n minus 1, so 63. Then same thing for x to the 16, 16 x to the 15. And for this one, it's going to be easier to rewrite it as x to the negative 0.5. So then you're going to have minus 1 over 2, which is just 0.5, times x to the 0.5 to the negative 0.5 minus 1, which is just going to be 3 over 2. Right. So it's actually good to, you should get in the back of your head know the derivatives of like 1 over root x, 1 over root 3 to the x squared, because these ones are very common. So if you can save time on actually doing the subtraction of the fractions and having to think about it, it'll save you a lot of time in the long run, especially if you're doing a more complicated derivative. So in this one, 1 over root x, we just did that to be negative 1 over 2 x to the negative 3 over 2 plus, okay, so this one we have, basically what we have is x squared times x to the negative 0.5, right? And what is it when two functions are multiplied or two exponents are multiplied? You can just add them, right? So it's going to be 2 plus 0.5, negative 0.5, which will give you 1.5, which is equal to 3 over 2, right? So it's going to be x to the 3 over 2. So that's going to be the actual function. So then you have 3 over 2 times x, and then 3 over 2 minus 1, which will give you 1 over 2, which is just 0.5, so, or otherwise root x. Then moving on, the derivative of x to the 14, 14x to the 13. Derivative of any constant is 0, so 0. F prime of x for this one. So very nice, to cancel out. 1 over 16 times 16, x to the 15, plus 5 times 2, 10, x to the 4. Using the power rule. Then we have another rational function. So let's move it up. So then we just have minus x to the 2 over 3. Right? Using exponent laws. So it's a negative, right? This is a negative right here. So it's going to be minus times negative 2 over 3. And then x to the negative 2 over 3 minus 1. So it's going to be negative 3 minus 3, which will give you negative 5 over 3. Right? And just to make it clear for you, negative 2 over 3 minus 3 over 3, negative 2 minus 3, negative 5 over 3. And for the last example, f prime of x is equal to, so derivative of x squared, 2x. Derivative of 3x to the 4, 12x to the 3. Derivative of 8x to the 54. Doesn't matter how big this number is, you just think of it as n. And when you think of it as n, if n, for example, is equal to 54, you just plug it into this formula, right? So I'm just going to do that. So the 8 was already there, so I'm going to multiply by 54, and then it's just going to be x to the n minus 1, so 53. And then, so we can just cancel these out, so we don't have to do the derivative, and it's just going to be a constant of 1, and the derivative of any constant is just 0. So it's just going to be plus 0 plus the derivative of this, of x to the 3 over 2. So it's going to be 3 over 2 times x, and then you have to do 3 over 2 minus 1. So 3 minus 2 is going to be 1 over 2. Right? And that is the video. So please leave in the comments if you have any questions. And have a great day.